Hi, I'm Francis Vigent, CEO of NoAtom. I'm pleased to be with you today. I apologize I can't be there in person, but I'd like to tell you a little bit about what NoAtom offers for California schools and districts who are interested to adopt the new California Next Generation Science Standards. A quick bit of background on NoAtom. We have been around since 2006. We're a group of educators who have developed curriculum materials and professional development, which is in use by hundreds of thousands of students all over the country, as well as really all over the world. So what do we mean by a complete K-8 solution? So what we mean is curriculum that is designed specifically for the new California NGSS standards. That curriculum is scope and sequence, lesson plans, teacher background, assessments, you name it. It's there. It's all chronological, intentional, thoughtful, and it's also backed up by research. Number two, we're talking about NoAtom's targeted professional development, which can be online or in person. We really view this as a professional learning opportunity for brand new teachers as well as seasoned career teachers as well. The third piece of our solution is integrated hands-on materials. Hands-on materials give students the opportunity to learn every day by being scientists and engineers. Okay, and the last bit is this phenomena-driven learning environment. What does that mean? It means that every unit, every lesson in our curriculum is driven by real-world phenomena, which children get to form opinions about and investigate hands-on through plans that they create in the classroom. And so you can see how these pieces come together in order to sort of support one another and support teachers in the classroom. So if you take a look, kindergarten through 8th grade, NoAtom follows an integrated model. What we mean by that is that we follow the standards progression recommended by the state of California. But also, when it comes to middle school, what you're going to see here is not a discipline-specific approach, which means a year of physical science, a year of life science, a year of physical science. Instead, physical, life, and earth science occurs within the same school year. And so when you look at our progressions, what you're going to see here is, with the exception of kindergarten, 9 units that are scaffolding within the year. And so what happens is it's almost like progressing through a tunnel, where as a student progresses through Unit 1 and Unit 2, they're making connections into Unit 3 and through Unit 3 into Unit 4 by design. Okay? All of this, again, being hands-on. When we talk about a lesson, we talk about a group of experiences around a phenomena. Again, with students' ideas and thinking at the center, and then exploring as scientists and engineers. Now, the curriculum itself is available 100% digitally as well as 100% in print. So whether you're a one-to-one district or a district that has very little technology at all, NoAtom is able to fit. What we include in terms of our curriculum is all reading materials, visuals, assessments, and these sort of things, but also videos, curated simulations, all kinds of different pieces like this, which allow teachers, if they have access to technology, to extend into technology-enhanced Socratic dialogue, as well as scientific discourse around specific phenomena. NoAtom has developed a tool which is in use all over called Soccer Circle. And what that is it's an innovative platform for sort of a cross between a group text and a private chat, which is moderated by the teacher it's set up and moderated by the teacher. And the purpose of this is to be able to do an inner circle, outer circle Socratic dialogue where students are able to share their thoughts in real time. And it's not necessarily one where you have to wait for the person who's speaking to end. We cover how that works in professional development, but there's a lot of kind of interesting pieces to this. Some of our key differentiators. Number one, NoAtom isn't focused on sitting students behind a computer and trying to have a computer teach the students science. Instead, what we're doing is we're engaging students in real-world phenomena that's something that they can think about, form an opinion about, and then the learning comes as they plan ways to figure out if their thinking is supported or not supported by real-world data. And so what that means is they form a plan which they carry out hands-on with the materials we're providing, and they do so in order to answer a question or solve a problem which they've developed. And that is basically a reflection of what scientists and engineers do. So the children are engaged in the STEM cycle, developing new knowledge, and using that knowledge to solve problems through prototyping and testing those prototypes. And what happens is that data then becomes the basis for scientific argumentation and better understanding, or basically looking at that initial thinking about whatever was going on, that particular question or particular problem. And what happens is that data then is an opportunity to say, yes, my thinking about the answer to that question or the solution to that problem was supported or was not supported based on the approach that we took in an experiment or in a prototyping engineering design process. Okay. What's important about this is that our approach is grounded in the latest research on how students actually learn, with a focus on developing thinking skills as students work to answer questions, solve problems for themselves. And this can happen in any kind of classroom setting. It can happen in a multi-purpose room. It can happen in a classroom. It can happen on the floor. It can happen at nice science tables. Okay. But the key here is that, if, for example, in this picture, these girls are working collaboratively as partners, and they are developing a plan from scratch, not from a demonstration that was shown to them, not from an artist's rendition in terms of a simulation. It's their own thinking, and they are going to take that plan and use the materials that are available as a resource base, and then actually carry out their plan, whether it's in a prototype or an experiment, to get the necessary data to understand and argue whether or not their idea is, let's say, true or false. In a big picture, phenomena-driven learning is the only way that children are able to build sort of a purpose and a network of understanding around these next generation science standards. And it's not only in California, but nationwide for those adaptive and adoptive states. Here's how that works in the case of NoAtom and with the California Next Generation Science Standards. That anchor phenomena that is a part of every lesson and unit becomes the basis for students to have scientific discourse, Socratic dialogue. And what that means is that students talk about what they notice. They think about this anchor phenomena as a group, and they inevitably bump up against the limits of what they know, and in particular, what they can support with evidence. And so this raises questions and problems where students can break into small teams, and that's how NoAtom's designed, and begin to plan investigations using scientific or engineering process, engaging those science and engineering practices. And through that planning process, what's happening is the students are getting formative feedback. They are in and of themselves formative assessments. And what that means is that teachers are engaging, or students are engaging with teachers in checkpoints, and at that checkpoint, the teacher is able to differentiate instruction. They're better able to understand their own effectiveness as practitioners, but also the children are understanding better through that interaction what it means to be to learn well, what it means to be an effective science student. And they're able to take that information back right away and incorporate it in their learning, incorporate it in what they're doing in that moment. So it's a win-win. It's a low-stakes assessment opportunity. So we have a number of these assessments that are part of every lesson and unit. Certainly plenty for grading. We have all the rubrics and so on as part of that. So you can imagine students go through this, they form an evidence-based conclusion. And why is that important? Well, because that evidence-based conclusion is an investigation into a little piece of that larger, more complex anchor phenomena. And so our debrief is not only on our results as teams and among the group, but it's also about the group reflecting back on that larger anchor phenomena. Okay. And so these things build. So this, what I've given you here, is sort of a high level, really quick look at a lesson. Now remember, a lesson takes place over multiple days. At the middle school level, you're talking a week to a week and a half. At the elementary level, it's similar. But again, this is all grade specific. Okay. Now, when it comes to no-atom materials, they're organized by unit. And I'm talking about hands-on materials in particular here. In your curriculum, the units are organized, but then the materials are organized corresponding to those units. So what happens is no-atom provides the consumables, the durables, everything you need for classes of 12, 15, 25, or 30. That's shipped to the classroom with the teacher's name on it. And when the teacher is on Unit 1, they use all the resources in their Unit 1 box. And when they're done, they keep the durables, and then they go on to Unit 2. If they have multiple sections, they get additional consumables only kits for those other sections. And same thing. Get to Unit 2, they have another set of boxes. And districts are able to contract with us. We have multi-year agreements so that, through implementation, there can be a set professional learning plan, implementation plan, and then on top of it, continuity in terms of all the logistics for curriculum resupply. And that includes live materials and everything. So we take care of all of that. One of the things that you'll notice here is in this picture is not only consumables and durable materials. Durables would be things like multimeters and so on, but that we're including paper copies of student readers. Why? Well, the reason is that all of the students' close reading strategies can be applied in these student readers. Any activity sheets, all the science vocab lists, all of that is built into those readers. And they're considered consumable because, especially at the elementary level, but it applies also to the middle school level, children can take those close reading strategies, apply them in the reader, and then that reader is almost like a miniature narrative. It's a little piece of a different style of textbook. It's a resource for accessing the phenomena through text features, vocabulary, and again, a narrative which is not explaining a word as much as giving context to a vocabulary word. All of our reading material is Lexile certified at grade level. And then when we think about things like using a wide range of materials to help students answer questions and solve problems as scientists and engineers, we want children to be able to engage in a productive struggle with their lab partners, to do so hands-on, and to see that real-life phenomena as the mode of learning. Okay, so hands-on materials is not an option; it's actually a conduit for mastery. And so the classroom becomes, like you see here, a next generation inquiry environment. The last piece I'll touch on here is professional learning, our approach to professional learning and how it's different from other providers. Number one, we really specialize in helping not just the classroom practitioners, but also administrative teams engage in new implementation of next generation curriculum. And so when you look at our curriculum for California, what we're talking about here is implementing not just curriculum, but pedagogy and expectations, because sometimes this can be a bit difficult to talk about, but the reality is that the expectations of three-dimensional learning are different than the expectations of prior standards that were largely fact-based. And also the forms of assessment mirror this. So what we're doing in terms of professional learning is really focusing on personalized learning for teachers and learning which is transformative in the form of practices and the approach to the standards. We don't go into professional development just explaining resources, but what we do is we provide concrete feedback and strategies to help teachers hone their own practices. And so our professional development model looks like it's a series of professional learning sessions. One is sort of in grade specific or grade span settings. And then what we do is we come alongside through learning walks to work with teachers in groups, professional learning communities, or even individually to reflect on practices and to really have targeted areas of improvement. So if you have any additional questions around anything I've talked about, please feel free to grab some sample resources. Check us out online at nowatom.com, KNOWATOM.com.